In a recent video, we walked through how to set up GPT-in-a-Box on a virtual machine. But if you're running your Gen AI apps at scale, you'll most likely want to be using Kubernetes. Hi, I'm Jordana, Technical Marketing Engineer at Nutanix, and today I want to walk you through setting up GPT-in-a-Box on Nutanix Kubernetes Engine. Let's dive in. So taking a look in Prism Central, we can see we have an NKE cluster here, and we have a node pool with a GPU configured to be passed through to it. We're also using a dedicated Nutanix files cluster for NFS, and we've created a share that we will use as a persistent volume into our NKE cluster for us to mount a share to store our model. So I'll go ahead and copy my path to the mount path, and now let's go ahead and set up our jump server. So the first thing we're going to want to do is make sure that our jump server has all the tools that we need. So we've already installed kubectl for managing our NKE cluster. We also have Helm for installing the NVIDIA GPU operator, which we'll see in a minute. And we're also using Conda to manage our dependencies in a virtual environment. Now this is optional, but it helps to manage our dependencies. So I'm going to go ahead and create an environment based on Python 3.10. And then once it's done, we can activate and start using it. Now that our virtual environment is activated, I'm going to go ahead and mount our NFS share. So I'll first create a directory, and then I'll go ahead and mount the NFS share to that directory. And now back in Prism, I'm going to go ahead and download the kubeconfig for my NKE cluster. So I'll copy this command out to the clipboard to set my kubeconfig environment variable. And I'm also going to go ahead and just tighten the permissions to make it a little more secure. So now, once that's done, we can see that we can run kubectl commands against our cluster. So now putting our jump host and our web browser side by side, we can start going through the open docs documentation for deploying on Kubernetes. So we're using version 0.2 of the Kubernetes package, which is the latest version as of the time of this recording. And looking at the Getting Started setup page, we can see that we've already accomplished many of these steps. So we have our jump node, we have our NKE cluster, and our NFS server. We have our tools installed on our jump machine. We've mounted our NFS share and set up kubeconfig. So now we can move on to configuring the NVIDIA GPU operator in our NKE cluster. So we're using NKE 2.8, so I'll go ahead and just copy these Helm commands to add the Helm repo and then do the install. If we were using NKE 2.9, we have the required config. The versions that you should pass to the Helm command, those are in the Nutanix documentation. And so once this is installed, we can see that our GPU operator pods are up and running, giving our Kubernetes cluster access to the GPUs. So next we can go ahead and download the Nutanix package and install the required Python libraries. So I'll open the releases page in a new tab and copy out the tar.gz file. And we'll go ahead and create our working directory in our jump host. And of course, let's pull that file in with wget, and then now we can untar that file into the directory we just created. So now that I've done that, we can go ahead and follow the rest of the instructions. So the next step is to install KServe into the cluster, which is a model inferencing platform that runs on Kubernetes. So I'll go ahead and copy and run the command here to install that into our NKE cluster, and it'll take a couple minutes as it installs all its dependencies. And once it's complete, we can move on with the instructions to install the required packages that are required for our Nutanix bundle. So I'll go ahead and just make sure that pip is installed, and then go ahead and run the install of the requirements, which will install things like the KServe Python module, Torch Model Archiver for creating the model archive file, which we'll use in the next section, and the rest of its requirements. So once our requirements are installed, we can move on to the next section of the documentation. So just like in the VM version, we have the 5 validated models, and we're going to be using the Llama 2 7B chat model. So we'll go ahead and run the generate.py script to download the model files, as well as create the model archive file. And I'll just need to pass it the model name. We'll pass it our mount point, which is where it'll place the files, and the model archive file, and then my Hugging Face token. So the script is pulling the model files from Hugging Face. Another option is to download model files from Hugging Face yourself, or if you're using custom model files and place those on the NFS share, and then you can skip the download portion of this process. Once our model archive file is generated, we can see that we have our model archive file on our NFS share, and we can go ahead and begin to run Inference on it. So the next step is to deploy the Inference server. Similar to the VM version, there's a run.sh script, but instead of running TorchServe directly, it's going to create the required Kubernetes resources and our KServe deployment. So we'll just need to pass it a few arguments. So we need to give it the name of our model, the number of GPUs we want to use, the NFS share where the model archive file is placed, and the desired Kubernetes deployment name. So now it's going to go ahead and start creating the required Kubernetes resources. So it's going to create the persistent volume for our NFS share and then create the Inference service. So once we have our Inference server up and running and the model is registered, we can start making Inference requests. And the next step is to use the Istio gateway that came with KServe to set the ingress IP and host ports, because we're not using an external load balancer. So you can copy and paste these commands directly, except for the service host name, you'll need to replace your deployment name with the name of your deployment. In our case, it's LLM deploy. I've saved my variables in a .env file, so I can just source that and have my variables set. And now we can go ahead and do a curl request. So in our working directory, much like in the VM version, we have a data directory with our sample text. So if we look at our QA directory, we have, our tell me about llamas prompt, but let's try something a little bit different. Let's try the Canadian provinces. So I'm going to go ahead and copy and paste the curl request here. I have everything I need already here. I just need to replace model name with llama27b chat, and then the input path to the data file that I want to use. So we can see that the Inference server is up and running. It's responding to our prompts. And now we can go ahead and run our chatbot app against it. So I have my chat app here. I have a version for our Kubernetes deployment. It's very similar to the one we did in the virtual machine, except we're passing it some commands to get the ingress host and the ingress port and the service host name. We could also be doing this with the Kubernetes SDK to make it a little bit cleaner. But either way, this will get what we need. Now we can go ahead and run our Streamlit server, and we can see that it's using our deployment, our LLM deploy Kubernetes deployment. So it's connected to our Inference server. And I can go ahead and ask it a different question about countries. I'm going to go ahead and use European countries this time. We can also see the endpoint it's hitting. That's our node port for our Istio Ingress gateway through to KServe, and we can see we got a response back from the chatbot app as well. So as we can see, it's easy to get up and running with GPT-in-a-Box on Nutanix Kubernetes Engine. To explore AI on Nutanix further, be sure to check out our test drive on running AI applications on the Nutanix Cloud Platform by navigating to nutanix.com/test drive. See you in the next video.